All right. Well, I know that a few others will probably be joining us, but we're going to go ahead and get started. And hello, everyone. Welcome to today's webinar, which is part 2 in this 2-part webinar series focused on APS, which is, of course, the acronym for Advanced Planning and Scheduling. I'm Chris Brewer, ATS Lean Scheduling International's Customer Development Manager. I'll be your moderator here today. For those of you who were not able to attend the first session, I'll tell you, we had a fantastic and informative time where our panel of experts discuss the ways that APS supports your lean initiatives. And we're going to provide you a brief summary of that session in just a few moments. But know that you'll have access to the recorded playback of both that session and today's following our conclusion. So now today we're going to pick up where we left off last time, honing in on the APS solution itself. But first, I'm going to introduce to you our panelists. First, we have Martijn Doctersloot. Martijn serves as the Global APS Business Development Manager for ATS Global. Martijn has over 15 years experience in business software consultation, and he's worked hands-on with clients' APS requirements for the past 10 years, and also has extensive expertise in ERP and supply chain BI. And alongside Martijn, we have Hans Albright. Hans, who serves as Vice President of Sales and Marketing for ATS Lean Scheduling International, has spent the last 20 years both selling and implementing APS and ERP solutions. And before that time, he actually was a production scheduler. So what you're hearing from him today regarding planning and scheduling, more than just words, it's his experience speaking. And again, we'd like to welcome you here. We're grateful that you've chosen to spend with us a valuable hour of your day. We welcome any questions that you may have. So at any time, please drop those over to us in the questions panel there, and we'll answer those at the end of the session. So with that said, I'd like to turn it over to Hans Albright. Hans?
All right, thank you, Chris. I appreciate that introduction. Okay, everybody, so I'm going to be brief here. I wanted to run over real quickly just an agenda of what we wanted to cover this morning, and then we'll go on. So as Chris mentioned before, I want to do a quick summary of last week's session with Dr. Shahrukh Irani, Paul Mittendorf from Horberger Corporation, Martijn, myself, and Chris. So just going to do a real quick run through, a summary of what we did there, and then I'm going to turn it over to Martijn, who is going to spend the remainder of the time showing you Op Center advanced scheduling. There will be a Q&A session, so we encourage you to use the chat box. If you do have questions, please put them in. We are monitoring that. And so from there, let's go. All right, so last week we started out with Dr. Shirani answering the question, what is lean? So to follow, basically he had a nice definition, a manufacturing philosophy that shortens the customer wait time between the receipt of a customer order and the shipment of that order to the customer. And the key to doing that is by eliminating waste. So any time that an order is delayed, the cost of one or more of these 8 different forms of waste that Dr. Irani also outlined gets added to the cost of producing the order. So the key here is to eliminate waste in the process from when an order is taken to when it's delivered. However, this really differs by product mix, right? There's a big difference between a low mix, high volume versus a high mix or high or low volume, or put another way, make to stock, make to order. And so what came out and what unfolded through Dr. Irani's sharing was that not all tools from the lean toolbox, if you will, work with high mix volumes, work with this make to order type of environment. Some will never apply and actually require a tool to fill that gap. Advanced planning and scheduling is that tool that makes it possible to take this concept that was built for Toyota, who's filling up parking lots across America as their inventory holding area, versus you possibly doing this really high mix, quick turn kind of work. And it's a very different kind of thing, but yet lean can work if you have an advanced planning and scheduling tool in those environments. And then we passed it off to Paul Mittenberger of Horberger Corporation, who has implemented both lean and APS, and he talked about his experience. So Paul has a very high mix environment. He mentioned that they have 400,000 part numbers, and the volume could be on any given machine. He could have 1 part or 100 parts at any given time. But to put it in perspective, 70% of the work that they run through their plant, the Herberger plant, comes from 120,000 SKUs. So high mix is absolutely the case, very high mix. So Paul came to the realization early that traditional lean principles simply were just not going to work in his environment. So he looked around and he learned then about APS. And so 12 years ago, Paul implemented Op Center APS scheduling and integrated it with the other systems on his shop floor. And Paul's statement was that he said that APS enabled the ability to viably and quickly create the best schedule, to keep resources optimized, to achieve the best workflow in order to achieve on-time delivery to the customer, which was the goal. So he gave them the example that when he went live with APS, he was really hoping they might see a 10 to 15% increase. And after the first week, they were able to confirm that they had achieved a 30% increase in their throughput. So that was a great story and a great experience that Paul shared of his implementing. And then Martijn and I took the questions of, well, what is APS? So briefly, it's a planning scheduling software that uses finite capacity scheduling engines. And again, the point to highlight here is finite capacity. And these systems can be very basic and simple or very, very complex, but the key to it is that they will match your production and business environment. We're not asking you to change everything that you do in order to fit this software. This software will work with you in the best way to achieve the goals that you have. So the output then of an APS system is an accurate and optimized scheduling of jobs on resources. And the key here is that it is real world. They have all the constraints in there that you have in your real world. So those real world limitations guide and direct how the schedule is built and put together. And then the way it's presented back, it's graphical, it's interactive so that you can do what if, and basically it's something that everybody can see and understand intuitively what the schedule is. Everybody's on the same page. So that's the idea behind an APS system. And then beyond that, just a few highlights from the experience of all the panelists and things that different people shared. Paul mentioned that when he implemented that he focused on primary resources at first, and then he realized there were other areas that he needed to optimize as well in order to make it work the best that it could. He gave the example of a steel cutting area where he initially just had, well, there's these inputs and outputs and you're not going to pay attention to what happens in there. But then he soon learned that he did have to pay attention to what was happening in those cells or in that area. And so he had to add that to the schedule as well so that it could effectively feed other areas of the plant. Sharuk then also explained the importance of tying together the ERP system, the manufacturing execution system, the advanced planning and scheduling to form this complete optimized loop. And then he added one more bit of wisdom from his experience, and that is that if you add to that water spiders, the people who run around and make sure that everybody has the equipment and everything staged as it needs to be, and along with competent supervision and management, and you really, really see the benefits of that type of an implementation. Martijn shared a fantastic example from a customer that he had who had a fire in their plant, a devastating fire. And I mean, it made the news, customers knew about this, and customers were starting to check in saying, okay, I need to cancel orders, I got to figure out where I'm going to get this done. But this customer, because they had APS implemented, because they had Op Center APS implemented, by 10 a.m. the next day, they were able to proactively reach out to their customers with new delivery dates, and they had basically rescheduled 3 months worth of work in order to do this, and they were able to do it all quickly in a matter of minutes, hours at the most. So that was a tremendous story of the power of APS to help in a situation like that. And then everybody agreed throughout the entire session, all the discussions, it became clear that Lean is a great set of tools. There's no question about it, but it's not one size fits all. And that not all the tools and principles from the Lean toolbox are going to work in high mix, make to order environments. Some of these principles simply can never apply, and you need to have an additional tool to make that happen. And the advanced Op Center Advanced Planning and Scheduling software is that tool that fills that gap and makes it possible to use Lean in these high mix, complex make to order environments. So with that, let's have a look at Op Center Advanced Planning and Scheduling. I'd like to turn it over to my colleague, Martijn Donkersloot, who's going to be sharing with us more about it and giving us an introduction to the software.
Thank you.
Okay.
Let me share my screen. So I'd like to first start with a very short introduction about the product itself. So can you see my screen of Center Planning Scheduling
Yes.
Introduction? Yeah,
Yes.
Perfect. So scheduling a factory is difficult, and the reason why is that 90%, I think 90% of the operations people we speak with, they put their data, the ERP data, into a Excel spreadsheet and then try to tweak it to create a useful schedule for the shop floor. And we all know that's extremely inefficient and time consuming and almost impossible to keep it up to date, and especially when changes occur, when you need to make changes, the calculation of the downstream impact is extremely painful. So the question is your planner able to find the best strategy for your company in a effective manner? And besides the complexity of creating that and updating a schedule, there are so many different stakeholders that are affected by the outcome of the schedule. And unfortunately, they all have different interests. So, and most of the time, these are in conflict, so to say. So the question is, how do you satisfy them all? So how do you satisfy the sales, as well as the manufacturing, as well as the finance department? Well, we know that they, one way or the other, they will complain anyway. So what we see in most cases that the customer is facing difficulties because creating an accurate schedule is very time consuming, and changes will occur on a day-to-day basis. So there is no time to keep it up to date. The work to list will become outdated as soon as you publish them to the people on the shop floor. So the people on the shop floor will get confused. They don't know what to do. They probably start working on the wrong orders, and then the different performance will become poor. Customers could start complaining, and once they start complaining, the planner needs to expedite and to chase those orders manually. And instead of being a strategic decision maker, he now becomes a firefighter. So the impact is known, I think, by most of the companies which are in this meeting. Sometimes planners are too busy; they don't answer your questions anymore. They seem to become overworked. So you could decide to hire another planner. If you don't, then the planner will automatically squeeze his planning horizon. It does not make sense to schedule 3 weeks in advance if after 1 hour it completely changed. As a result, there's no insight in the real capacity and the constraints of your plans, and they will start overloading your shop floor. You will see all these work in process up front of your machines, and the lead times will become longer and longer. And at a certain point, more and more orders will become rush orders. And then you risk the fact that your customer won't accept anymore and is considering to leave. So in terms of a business case, you should not only focus on the visible costs, like the time spent on scheduling, you also should have a look at the hidden costs. So how does a poor schedule affect your business? And as mentioned before, several departments are involved. So the impact, this one. So the desired situation is that you have a team of people working together, and the system itself, it considers sales data, it considers resource utilization, resource capacity, labor availability, material supplies, and therefore it connects multiple disciplines within your organization. So this picture shows a team of people that needs to decide. So on the right-hand side, we have operations planning. On the left-hand side, the guy is the sales guy, and the left-hand side, a woman is a logistics, is run someone from the logistics department. And by sharing the information about the current utilization, the sales guy now understands that it does not make sense to promise delivery dates, which were not achievable in the first place. And as a result, the logistics department does now have the opportunity to postpone purchasing the raw materials for a couple of weeks. So by sharing the data and having the insight up front, we enable your team to make better decisions. So the objective of implementing a scheduling system is, of course, to speed up your scheduling process, to create accurate schedules in a very short period of time, to create what-if scenarios, and comparison allows you to have more insight in the real availability of your resources. And once you create a schedule, you should be able to publish these feasible work-to lists to the shop floor. So if you publish them and you have the opportunity to update, we can also capture the updates from your shop floor, and if needed, you can then reschedule and publish again. So the benefits, of course, it's not only, as said before, saving time, but utilizing your planners in a smarter way. So instead of entering data in Excel all day, we try to make them more strategic decision-making people within your company that can find out the best strategy for your company at that time. We want to create a controlled way of work for the people on the shop floor, so that they don't need to spend time on non-value added activities. We want to reduce overtime and outsourcing. As said before, create the synergy between sales and operations that allows you to lower your inventory, and that will definitely result in better margins. In terms of delivery performance, we like you to be able to determine reliable delivery dates, and that will definitely improve your customer satisfaction, and you will probably be able to sell more. So the software we are going to show you is called Ops Center Scheduling, and it's often used as a first step in a digitalization journey. It's a user tool, gives you a graphical presentation of your production plan. It allows you to drag and drop operations across your Gantt chart. You can easily change priorities. You can manipulate your schedule. You can create multiple scenarios. And most of all, you can see the impact on all the orders, on all the resources for a very long horizon if needed, before you're going to commit changes and publish your new sequence to the people on the shop floor. So it considers your material supply date, so stock file, actual stocks, and also purchased orders. That allows you to lower your stocks, which I'm going to show you during the demo. It captures your demand dates for the sales orders or for the stock replenishment orders, which allows you to guide your delivery performance. Gives you insight in the resource capacity and utilization, which is needed again for your capable to promise. It makes use of a multi-level bill of material, which connects your semi-finished product, your final products. That means that your schedule will become more accurate, especially when there is a delay on one of these levels. We use a lot of color coding, highlighting options, so you don't need to check everything one by one, but you can focus on the exceptions. And again, the planner is still in control. So if he or she wants to override the system, it's perfectly fine. So as I said before, there are several departments within your organization that will benefit from the outcome of the schedule. These are just a couple of examples. So now I will switch to the software, and hopefully we are able to show you everything we discussed today. So let me share my other screen. So can you see my Op Center scheduling screen now, Hans?
Yes.
Yeah, perfect. So this is the Op Center scheduling workspace. It's a easy to use interface from where you can access your data maintenance, for example, your configuration area, and your access. You can access your help and support. Within the main workspace, you can see that the system is designed to interface with other systems. So we can import data from any data source that's that can supply us with data. We make a distinguish between static data, which is the the data that won't change that much. So for example, your resources. So in this case, we have a small environment where we are going to manufacture different types of bikes in different colors and different metals and stuff like that. So therefore we have metal machines, welding stations, a painting booth, two types of company assembly lines, wheel assembly and the final assembly. Besides the static data like the resources, but also, for example, the type of metal you're going to use. So within the demo environment, what we are going to show you is that each and every time you change from metal 1 to metal 2 on the metal machine, there will be a changeover time involved. Will be calculated on the fly. But in terms of visibility, you like to have some color settings as well. So if you want to change these color settings, you can apply whatever you like, and then the system will automatically adapt these changed colors to your gen chart. So within the products table, we maintained our routings. And of course, this can also be imported from an ERP system. So for example, in this case, we know we need to produce 3 steps, so 10, 20, 30 before we're able to produce a frame. We know which resource group is capable of executing this specific operation step. We know the timing, so in this case, the time per items. We know the metal we need and stuff like that. So within the editor window, we can sort, we can filter, we can use wildcards, we can reorganize these column headers if you like. We can even rename them to your own jargon if you like. So the dynamic data in this case is more dynamic in terms of it can change every day. So for example, your supply can change every day. In this case, we know from a warehouse management system what the actual stocks are, but we also imported the purchased orders from your ERP system with the expected supply dates. So from a demands perspective, we know that this is a make-to-order environment, so we know what types of bikes we need to deliver to which customers. You could also consider this as forecast orders or material replenishment orders, and we need them to guide the end time of the operation. And we want to compare them with the due dates of these orders to make sure that we are still on time. So based on the ERP imports, we can import all these works orders. We can also create them by the use of Op Center if you don't have a MRP routine within your ERP system, or if your data is not accurate enough to run that routine, then we can help you with that by the use of Op Center. And this is the workload we need to schedule during the demo. And then last but not least, we also have what we call a bill of material, which will connect all these individual works orders. So for example, if we want to create this mountain bike, we know that in the final assembly step, we need saddles, which is a purchased item. We need mountain bike frames, which is a make item. We need wheels and we need pedals. And these are all make items. So we will show you that we are able to connect all these different orders together to make sure that they're all finished when we start the final assembly. So let's see. So once we imported all the data, and by the way, we can enrich your data. So if you don't have all the data available within your MES ERP system or any other system. We can also maintain the data within Op Center itself, and during the import, we will enrich the data for you. So once we imported the data, we are able to generate a schedule. We can compare different scenarios, and once we choose one of those scenarios, we will release a schedule. Releasing a schedule means that we will supply the data to another system. So it could be your MES system, could be a ERP system, shop for data collection system, whatever you have in place. And if you don't have anything in place for your shop for updates, we can also create some reports for you to instruct your people on the shop floor. So let's have a look at the sequencer. So in this case, we have here we are. So in this case, this is the sequencer, and I've divided my screen into 3 areas. So one is the editor window, similar to what we've seen in the products table. Again, the data you can filter, you can rename, you can resort, you can do whatever you like. Then the main part in this case is the overview window, which is your gen chart. And then on the right-hand side, we have got our unscheduled operations. And actually, this is our to-do list. So I like to explain it step by step. And then at the end, I will create a full-blown schedule by just one mouse click, or I will create multiple schedules, by the way. But just to give you a better understanding about how it works, I like to do it step by step first. So the gen chart itself on the left-hand side, we will see all your resources. On the top, we will see your horizon, and that can differ per company. So it could be a couple of months, maybe even more. And we can zoom in. So if I use my control and my mouse wheel, you can zoom in into more details, as you can see here. So this demo environment has a fixed time, fixed date. So in our demo, it's the 10th of January in the year 2000. Half past 5, and this terminator line here, you can see the red dotted line is the now. So on the left hand side it's the past, and on the right hand side it's the future. So what we can see here is that there are different templates, so different shaded areas. So in this case, the white area is the on shift period, and the shaded area is the off shift period. So we don't have capacity available from midnight till 6 in the morning. Then we start working from 6 to midnight, and each and every resource can have its own resource template. So you can change from off shift to overtime to weekend shifts. So we will model that together with you. You can apply that very easily. And the same I did for Metal 1. So Metal 1 has a red bricked pattern shown, which means that it is in a breakdown. So as you can see here, each and every resource has its own calendar template, and we just clicked here to enter a breakdown from 5 o'clock in the morning till 12. So that's very important to have a better understanding. So the white space is the finite capacity, and the shaded area is a off shift period. So there is no capacity available. Okay, so on the right hand side we can see all these icons. They have different color settings. We can change the color settings. So I just showed you the color settings for the metal. So let me change my properties here. So if I want to see what type of metal I'm going to use, so I've got blue, purple, green, orange. Okay, so I just changed the orange color settings for you. So next you also have what we call a tip tool display. You as a user, you can alter this tip tool yourself. So if you want to see more or less, you can change that yourself. And at the end, we need to place all these individual operations onto your gen chart. And there's one thing left I need to explain on the gen chart itself. We talked about the dynamic data, which was your current stocks. So here I can see that I have a stock file that informs me that I've got 200 pieces of settle 1. I also have purchased orders. So for example, this purchase order number 17 will supply me with the tube number 4 items on the 11th. And if I zoom out a little bit, I can also see my demands. So these are my sales orders. This is a make to order environment. So these are my sales orders. So you can see what you need to deliver to which customer at which date. So the scheduler, let me drag and drop some of the operations. Let me filter here on the cut tubes, which is the first operation for the metal. I can drag this operation onto the planning board, but I'm not allowed to drop it onto each of these resources. So you cannot cut your tubes on the final assembly line, but you're able to do that on your metal 1 as well as on your metal 2. So as you can see, the length of the bar is now calculated by Op Center, and it depends on the efficiency of your resource, the quantity of products you need to make, the rate per hours, and of course your finite capacity. So if I choose to start just before an off shift, you will see that the length of the bar will be automatically adjusted based on the off shift period. Does not mean that we need to work more hours, but it takes more time because we have an off shift period in between. And if I decide to schedule this specific works order on metal 2, you will see that the length of the bar will also be adjusted. And that's because the metal 2 machine is a little bit older machine than the metal 1, and therefore the rate per hour is less than the metal 1 machine. So let's drag and drop another operation onto this planning board. Let's take this one. So you can see that the finite capacity of your resources is now occupied by the use of these bars. And now I see something different here, and this is what we call the changeover time. So from this type of product to this type of product, I need to change my tool sets because of the metal that changes. So this is the aluminium, and this is, let me see, the titanium. So in between those two operations, there is a setup time involved. If I put it in between, then I've got 2 setup times. So this is what we call the changeover times that can be calculated on the fly and affect your efficiency. So we are going to do some scenario planning in a minute where we can show you that we can reduce your setup times and increase delivery performance, for example. So there's something else here. So the pattern changed from this specific operation, and there is a green line and the text is green. And if I highlight this one, you can see that there is a red dotted line connecting to this specific purchased order. So that means that if I schedule it over here, I schedule it too early, meaning that the materials are not in while I'm trying to consume them. And now I did it manually, but it could also appear when you import your ERP supply records in the morning, that, for example, this delivery is delayed and therefore this order is scheduled too early. So you need to repair your schedule based on this new reality. So for now, I'm going to put this one before that one, and now my problem is solved. So I've got one changeover time, and no issues with my delivery performance anymore. So of course, this is only one operation. So let me show you that we have multiple operations for creating a frame. I click here on the right mouse button, place on blend board, forwards over operations, and now you can see that the scheduling engine automatically allocated to the right resources. And I choose metal 2 because metal 2 is able to finish earlier than metal 1. So if I place it on metal 1, you can see that the end time is later than if I use it on the metal 2 machine. What we also can see is that there is a connection between these operations. That means that in this case, you need to finish this operation completely before you're allowed to start this operation. So some customers want to reduce their lead times, and they allow a little bit of overlap, parallel loading. So in this case, we are allowed to start the next operation if we produce, for example, 50 of those first operation. So we can shorten your make spend. Some other customers want to have some spare time in between because there is a cool down process, or they want to have a little bit of slack time because they need to transport it from one area to another area, for example. So these are out-of-the-box features that we can apply to your environment as well. So let's have a look at the let's schedule a complete bike. So in this case, let me take this demand order, for example, this sales order number 14, and I ask the system to highlight all previous operations, meaning that it will now highlight only these operations that are connected to this specific sales order. So as said before, we need to create these frames. We need to assemble hubs, pedals, and rims, and the pedals, the hubs and the rims together will allow us to create these wheels. So when I schedule this set of orders, I can generate schedule. You will see that. Let me enlarge my screen for a minute because I don't need the editor window anymore. So you can see that the system now is aware of the relationship. So not only operation 10, 20, 30 from one individual works order, but also the fact that you cannot start assembly a wheel if you don't have assembled the hub and didn't shape your rim. So here you can see they're all connected. So this is done by the use of the bill of materials. So in this case, we also need to, let me see, assemble the pedals. And the pedal assembly is postponed. And I will show you what will happen if I drag and drop this one to the left-hand side. You can see different pattern, red, green text, green line, red dotted line here. So the system automatically recognizes that there is a need for materials, and the materials are not in before the 12th of January. And therefore, you cannot start your final assembly earlier because you need all products. And remember what Paul mentioned last meeting, if you have 95% of your items on time, it will become a disaster because you cannot assemble the bikes. So let's have a look at the, for example, this supply record here we talked about earlier. So let me, let me check this one. So assume that this order is delayed, and I will now change it within Op Center, but normally this is data that is coming from your ERP system, of course. So assume that this is your situation. You can immediately see that there is a warning sign, the green line, the green text. We also have a lot of highlighting options. So highlight early operations will give you all the information you need. So if this is the case in the morning, so this is postponed by 5 days, you need to act, you need to react, you need to repair in this case. So let me repair my schedule and then see what will happen. So the repair button allows me to change sequence and stuff like that. I don't want to go into more details now, but as you can see, when I repair my schedule, it will not only postpone the related operation for this specific supply, but it will also postpone my final assembly because you cannot assemble if this part is not there. But as a result, you can see there's a lot of work in process created. So let me unschedule and reschedule again, but now I want to schedule backwards. So now the system is calculating when it needs to start at the latest to be able to deliver just in time. So this is the shortest lead time for creating those 25 bikes. So it's around 2 days. This is what we call the just-in-time principle. Okay, so what we just discussed is that the scheduling system knows the finite resources. It allows you to make use of your finite capacity, so it knows when a resource is occupied and when it's not occupied. It took in consideration your material availability, your operation relationship, but also your order relationships. We changed a supply date and we repaired our schedule based on that. Not only the related product was delayed, but also the final assembly product was delayed. And we talked about highlighting functions, backward sequencing, and shorten your make span. So having said that, I'm pretty sure that we applied most of the basic rules within a company. So that also allows us to schedule all the operations at once. And remember the planner in my example, who is now a firefighter. So what I like to do, I want to schedule forwards based on priority. So some customers have a higher priority than others, or maybe the sales guy is shouting harder, I don't know, but we like to schedule based on the priority. So we are going to schedule, in this case, 225 operations for the next 3 weeks. It's a limited set of data, and we can apply this same routine for tens of thousands of operations, and it will perform in a similar way, but it won't allow you to get a better understanding, because then the planning board is so full of operations that it is very difficult for you to see what happened. So let me schedule these operations, and it takes me 1, 2, 3, 4 seconds to create a feasible valid schedule. So we applied all the rules we discussed before, and this is perfectly fine to release it to the shop floor. It took in consideration all the business rules we talked about, and as a result, we now, as a planner, can focus on trying to improve the output of your schedule, output of your plant. So instead of entering data all day and then releasing inaccurate schedules, we're now created a schedule in 4 seconds, and we're now able to find out if we can improve the outcome of the schedule. And therefore, we have the ability for the schedule statistics. So in this case, the on-time delivery will be 90%, almost 90%, and that's not okay. So you can see here all the red text, red lines. That's not doable. So we like to reschedule. So I don't want to schedule based on the priority. I now want to schedule based on the due date. So it takes me another 5 seconds to create, or 4 seconds to create a schedule. And as you can see, no red lines, no red text. And the schedule statistics give me now the answer that I have a 100% delivery performance if I execute this schedule. What I like to do now is to focus a little bit on the setup time. So I have got a total of 2 days of setup time and 3 hours. And that's because of the metal that we used, and we changed from one metal to the other. The metal 1 and metal 2 have these black bars in between. So before we are going to create another schedule, I like to change my color settings, and I only want to focus in this case on, on the metal machines. So let me reschedule, and let me apply what we call a weighting rule. So most of the planners do have a gut feeling about how to improve efficiencies and stuff, but they don't have the tool to test it. So in this case, I can add priority to whatever I like. So we did it on due date. We already scheduled something where we used the due date as well as for the priority, and now I want to do it on the metal. So I want to group as much as possible of the same kind of metal to avoid those changeover time. So as you can see, it grouped all the same kind of metals together. There's one exception here, which is the green one, which is between the blue ones, but you're not allowed to schedule it earlier because of the material supply, so that's reasonable. You've got still the opportunity to change whatever you like. And again, for example, repair your schedule, not allowing to schedule orders earlier. So this could be a a schedule that you now created. Let's have a look at your schedule statistics. So delivery performance is lower, but we saved a lot of time on the setup. So let me save this one to compare it later on. So save schedule, copy, and this is based on metal. Okay. So now I want to combine both metal as well as delivery performance. So I will add a little bit more priority to the delivery performance, create another schedule, have a look at the schedule statistics, and I see 100% and a 1 day, 21 hours of setup time. So I think this is a valid schedule. Let me save this schedule as well as a combination schedule. Combination. And now I want to have a little bit more insight in the differences between our schedules. So therefore we have a KPI report available. So let me open that one. And I want to compare my metal one with my combination one. And you can tell us what kind of KPIs you want to compare. So in this case, we are going to compare the make span, the setup time, delivery performance, total lateness, and the costs. So the one that was, let's say, optimized based on the efficiency, has a longer make span, has a lower delivery performance, but has a lower costs involved, while the combination one is exactly the other way around. So we have these specifications available that we can see per week how it will evolve. So this gives you the opportunity as a planner to make better decisions, to compare schedules, to ask your colleagues what they or finance or operations or logistics, what they like, what they prefer, and stuff like that. So once we choose for, let's say we choose for this specific schedule, we now have the ability to publish the schedule to the shop floor. As said before, we can feature the data back into your ERP system because we now know for each and every operation to which resource it's assigned, to which resource it's assigned. We know the expected start setup, start time, and end time. So this is actually the information you need to instruct the people on the shop floor. If you have an ERP system with the shop floor module inside, then we can feed it back to that module. MES is also used very often. Shop floor data collection systems can be used. If you don't have any system in place, we can supply you with these kinds of reports. You can publish these reports, by the way, into a network environment in your IT environment. We can make them digital, by the way, so that's also possible. Work to list for metal 1, for example, for the next 3 days. So this is what we expect them to execute. So this is what we talked about about the controlled way of work. So each and every time we update the schedule, these reports will be refreshed. So from a painting point of view, which is somewhere in the middle of the routing, you can also see that we know that the material we are going to paint is coming from the welder 1. We know when we expect it, and we know when we are finished that a next operation is waiting for our products. So this is also supports your Scrum meetings. And if an operator needs help, he knows how critical his operation is at that time. So we talked about shop floor updates. We talked about adjusting your schedule based on, for example, breakdowns. So let me enter a breakdown over here. So it starts at 5, and it will probably last till 12. So when I have a look at my schedule, sorry, it's a working day. I need to break down, sorry. Okay. So it took me 2 clicks, 3 clicks to enter it. All the operations are pushed forwards. As a result, your schedule is out of sequence. So you need to repair your schedule. I will repair my schedule, can create different scenarios, choose the best one, and then release the schedule again to the people on the shop floor. So this is about updating your schedule, which is most of the time even more complex than creating one. So last but not least, we talked about delivery performance. We talked about capable to promise. So one additional window can be very useful, which is called the trace chart window. So within the trace chart window, we have the ability to what we call to normalize your trace chart, and then we can see that the horizon changed. So this is the number of days till the due date. So we can see that if we zoom in a little bit, that as a result of this breakdown, one order will become late, and it will become late in this case for 18 hours. Okay, so you now have the ability to inform your customer that there will be one order late, which is then delivered the day after. And of course, we do have those reports available as well. So assume that there is a sales guy who asks you, can we deliver 25 bikes? Then we also have the ability for the order inquiry, which is the last topic for today. So I test it because I don't have an order within my ERP system yet. So I test it here. What kind of bike they want to have is irrelevant. We do have the templates available. They want to order 20 of those bikes, and I ask the system to keep track of everything that we need. So materials, supply, materials, finite capacity, and stuff like that. And then it gives you the answer. So you're able, based on your current stock files, based on your current capacity, you're able to deliver these 20 bikes on the 25th of January. So this is what I wanted to show you for today. It's a lot of information in a very short period of time. So maybe I can hand over to Hans. Are there any questions that we need to address as well?
Yes, there are a few that came through, and thank you, Martijn. That was a lot of information, as you said, and you covered it well. And we did have a few questions that came in, so I'd like to just throw these out there quickly. We have about 5 minutes left. The first one that came through is someone that specified that they are in food and beverage, and the question is APS a fit in food and beverage? But I'd like to adjust that question a little bit and ask, is APS a fit in any industry, in all industries? Because I know we have many represented here today.
Yeah, I'll be happy to address that, Martijn. Of course, you're welcome to chime in if you wish. Yes, it is. And again, it goes back to the way the product is designed. It's designed to be configured around your processes, around what you do. So even when you have really complex work, like in the beverage industry, the food and beverage industry, where perhaps you have time phase activities where something has to go and then sit for exactly a week or whatever, working with tanks, filling and draining tanks, there's a lot of stuff that goes on that this is a tool that you're able to take the logic and the rules that you use to manage those things, put it into the system and let the system do the heavy lifting for you. And then as Martijn showed, you're able to come back and make adjustments after the fact to see if maybe you can optimize, tweak, put a priority on a customer, those types of things. So again, the answer is absolutely yes. The tool set is there and it's designed for that.
All right, thank you. Another question here, and this is a great one for you, Hans. I know you've got a lot of experience with this, and they said, we have JD Edwards as an ERP. Is there a seamless integration? So JD Edwards is one example, but I think you could probably, like the first question, kind of expand upon that a little bit, right?
Yes, absolutely. So JD Edwards, absolutely, slam dunk. But beyond that, like you said, we pretty much have yet to meet an ERP system that we cannot talk to, work with, pass data back to. Now, again, we're not going to necessarily pass data directly into your ERP. Very few people want us to, you don't want us to touch your database, but we know how to do all of the configurations, the integrations so that it passes back and forth very cleanly. So
Excellent.
yes.
And last question here before we wrap up, and that is, how do shop floor operators know what's in the schedule? And I know, Martijn, you had mentioned a few times about publishing the schedule, but there's multiple ways to do that. So maybe you guys can just kind of explain what that publish actually is, or what ways that schedule can be published.
Yeah. I know that I have seen where people will publish it to monitor. Perhaps each department would have their department's schedule on a monitor. It could be delivered to any URL, so that somebody would be able to pick it up on a tablet if they wanted to. Quite often, though, we're feeding, as Martijn said, we're feeding an MES system where people, that's their work queue, right? The schedule determines their work queue so that they don't have to worry about what their next job is. It's lined up for them. All the materials and everything should be there, and they should be able to work right down the schedule that's published to the MES. Martijn, I don't know if you have anything to add to that, or if that kind of captured your experience as well.
Yeah, well, exactly what you mentioned. So it depends on what modules the customer has in place already. We can feed the data back into those modules, and if there is no module available, then we have the ability to either create a digital report that allows the customer to start and stop, but we also have add-ons to track operation progress in a very easy way, and the information can be used to update your schedule again. So
right.
Excellent.
The close loop.
All right, and with that, I think we're going to wrap up today. Thank you, Hans and Martijn, and for everyone who joined us today. And where do we go from here? That's the question. You for the last 2 weeks, you all have seen lots of information, and where do we go? And certainly, you see the contact information there on your screen. We would love the opportunity to speak with you, to answer any further questions you have. But one great opportunity that we have is that we are going to offer a workshop. If you are interested in having a workshop with us where we will install a trial version of Ops Center APS, the software you saw there, get you started, get you set up, get some data in there, and let you kind of get your feet wet, we would love that opportunity. And I encourage you, give us a call, send us an email, reach out to either of these gentlemen here who would love to talk you through that. As well as I mentioned earlier, that you have access, or you will have access to the recorded sessions, both of last week on the lean discussion and today when we saw the demo. All of you will have access to both recorded sessions later today. Again, we thank you for being here with us, and we hope you enjoy the rest of your day. Thanks a lot, guys.
All right. Thank you, Chris. Thanks, everyone, for joining.
Bye-bye. Thanks for joining.